And let's get started on this. If you recall what we said when we have a problem of this type, where we have a polynomial, actually the top happens to be a trinomial, and we want to divide it by a monomial, what we do is we rewrite the whole example by putting each of the terms of the polynomial over the monomial. In other words, we'll put the 15 x cubed y squared over the negative 5x squared y squared minus the 30 x fourth y over the negative 5x squared y squared plus the 5x squared y squared over the negative 5x squared y squared. This is called divide. The instructions would either say divide or find the quotient. The word quotient means the answer you get when you are dividing. So this is a division of a polynomial by a monomial. And what we do is we take each one of these separate fractions and reduce them. Remember how we do that? We first take the coefficients. Here's the 15, here's a negative 5. When the negative is in the denominator, then we're going to use the negative as part of the common factor. The common factor is negative 5. This is canceling out. Negative 5 into 15 gives me negative 3. We really prefer not having my final answer with a negative in the denominator. Then we deal with the letters, the x cubed and the x. We always cross out or cancel out the lower exponent and subtract that from the higher exponent. So plain x is x to the 1. I'm sorry, this is supposed to be an x squared. I left out the square. But anyhow, x squared is less than x cubed. So we cross out the x squared, and 3 minus 2 is 1. I'm left with a negative 3x on top. And then the y squared and the y squared, they both cancel out because they're both the same. In other words, when you get 0 as an exponent, it means it's canceled out. Now notice that means that you're left with a 1 in the bottom because nothing is left there. So my final answer for the first term is negative 3x over 1. And we don't have to, when the 1 is in the denominator, we could write our expression without that 1. Then we go to the next. Now this is a negative 30 because this negative really goes to the top. And this is a negative 5. So I can cancel out the negative 5. And negative 5 into negative 30 will give me the plus 6. With the x's, the x squared cancels out. The x 4 minus 2 is 2. So this becomes x squared. And here the y is the one with the lower exponent. That cancels out. And 2 minus 1 is 1. So we're left with a y in the denominator. Remember, you're always left with the variable where the larger exponent was. So my second term comes out to be plus 6x squared over y. And finally, my last term, the 5 and the negative 5 cancel out. Gives me a negative 1. The x squares cancel out. The y squares cancel out. Notice everything canceled out. Don't leave it blank. It is, when everything cancels out, you're left with a 1. So the final answer to this example came out to be negative 3x plus 6x squared over y minus 1. And that's how you divide a polynomial by a monomial. And that's where we were left off last time. Anybody have any question about that? Okay, so let's continue from here to the next step, which is dividing a polynomial by a polynomial. Okay, so I'm going to erase this so we can start the next. Now, when we're dividing, and by a polynomial, we're always going to do something called long division. We're going to actually set it up like a regular division problem. The type of polynomials that we're going to be dividing by are going to be binomials. Now, actually, this can be extended. You could divide any polynomial by any other polynomial, but for our purposes, we only have to worry about dividing by a binomial. In order to remind you, because what we're going to be doing is long division, I'm going to do an example using long division. And then I'm going to regular long division with numbers. And then I'm going to show you how actually we're doing the exact same thing when we do division of polynomials. So let's say, I'm going to do it right over here. I'm going to divide 25 into 46/28. Okay. And I'm going to write down the steps as I do them. So what do? I want to divide by 25. But to divide by 25 on this whole long number, it's not something I can do. So I want to do it in stages. So instead of dividing the 25 into the whole thing, I start by dividing the 25 into the 46. And I estimate how many times do I think 25 will go into 46? And I'm going to try 1. So the first step I do is I divide. And I try it. Sorry. Having such trouble today. So I divided the 25 into the 46. Then I take the number that I put on top, the 1, and I multiply by it. I multiply 1 times 25, and I put the 25 underneath the 46. So that's my second step, multiply. What's my next step? Well, I'm sure you remember. What you do is you subtract. You subtract the 46 minus the 25. Now that's giving me 21. So that's step number 3. You do this subtraction. And after you do that subtraction, you then bring down the next number, which is the 2. That's step number 4. Let's call it bring down. And guess what? We just start all over again with what we were doing. So we start again by dividing the 25 into the 212. Now 25 into 212 I think goes about 8 times. So I'm going to put an 8 on top. So I've done the dividing. So now I have to multiply. What I multiply by is the number that I just put on top. I just put an 8 on top. I multiply the 8 times the 25. So 8 times 5 is 40, and 2 times 8 is 16, and 4 is 200. 8 times 25 is 200. I now multiplied, so the next step is to subtract. 212 minus 200 is 12, and I bring down the next number, which is an 8. And I go back to the first step again. 25 into 128 I think goes about 5 times. 5 times 5 is 25. 5 times 2 is 10, and 2 is 2. So that's 12. And I multiply, then I subtract. 128 minus 125 is 3. And there's nothing more to bring down. What sometimes we do is we put a decimal point and then we keep continuing. But what I want to do is talk about this number. This is what we call the remainder. This, in other words, if I divide 25 into 4,628, I get as my quotient 185 with a remainder of 3. It didn't go in evenly. I had 3 left over. What we very often do is we take the remainder and put it over the divisor and say that our answer is actually 185 plus another 3 over 25. And with numbers, you could just put them one right next to each other, 185 and 3 over 25. You could write your answer this way. Notice when you have a fraction next to a whole number, it means that the two of them are being added, 185 and 3/25. And that's how long division is done. This is not anything new. You learned it in elementary school. You didn't learn it in college, I'm sure. But I want to show you, the reason I went through this is so that I could show you how this is actually the method that we use when we are dividing polynomials. So if I, let's say, told you I want to divide 2x squared minus 7x plus 9 by 2x by x minus 2. I am dividing 2 polynomials. I'm dividing a trinomial by a binomial. Notice this is not what we did before. Before we had a trinomial, we divided it by a monomial, a single term. Here we have 2 terms because we can see a minus in between the 2 of them. Anytime something, a plus or minus separates 2 letters or a number and a letter, means that we have more than 1 term. In order to do this kind of division, we have to set it up like a long division. In other words, I have to put the x minus 2 on the outside. X minus 2 is what's called my divisor. And the dividend, what we're dividing into, goes on the inside of the division side. We have to be very careful that our terms are in what we call descending order. Highest power, next highest power, next highest power, which it is. And then we go and do the exact same thing we did in regular long division. We take the x minus 2. We want to divide it into this whole thing. It's very hard to divide by x minus 2. So instead of dividing by the whole x minus 2, we'll just divide by the x. We'll take the x, the first term, and divide it into the first term. So remember, x really means 1x. So 1 into 2 gives me 2. X into x squared gives me x. Now, contrary to that, where it's very important that where you put the numbers is that you put them on top in the right position. When you're doing long division with polynomials, it doesn't matter where you put the things on top. The placement of the terms on top if you didn't put them in the right place, will not affect anything. Okay. So we did the first step. We did our division. The second step is multiplication. We take what we just put on top, which is 2x, and multiply it, and we multiply it by the whole polynomial, the whole x minus 2. We multiply the 2x times x, and that gives me 2x squared. And then I do the 2x times -2, and that gives me -4x. So when I'm doing the division, I'm really estimating, so I'm just using the first term. But when I'm actually doing the multiplication, I multiply it by everything. Okay, my third step is to subtract. Now, when we're subtracting over here, this is just regular arithmetic subtraction. But over here, we're really subtracting with using algebra. So I want to use the rules of algebra when I subtract. And remember what the rules of algebra tell us. When you want to subtract, just change the sign of the thing that you're subtracting, and then you could just add. So if I want to subtract the 2x squared minus 4x, I'm going to take the 2x squared and make it into a negative. And I'm going to take the -4x and make it into a positive. And then I'll just combine the numbers. 2x squared and -2x squared cancel. -7x plus 4x is -3x. Okay, so now we did our subtraction. We do the fourth step, which is bring down the next term, which is the +9. And start the process all over again. Take the x and the first term and divide into the -3x. First term into first term. So this is a 1 that divides into -3, gives me -3. Remember, the x's cancel out. So what I get on top is -3. I now take what I put on top and multiply it by the whole divisor. -3 times x is -3x. -3 times -2 is +6. After I multiply, I now have to subtract. In order to subtract, I'm going to change my sign. So this one is a negative, it's going to become a positive. This is positive, it's going to become negative. And the -3x and the +3x cancel. And now I have a +9 minus 6, which gives me +3. And there's nothing more to bring down, so my remainder is 3. Just like I did before, I can put the remainder over the divisor. So I get 3 over x minus 2. And I can write my final answer this way. My quotient is 2x minus 3 plus the remainder, which is 3 over x minus 2. Now, I can't just put this next to the 3 because once you have variables, it looks like when you have two things next to each other and they have variables, it looks like you want them to multiply, and you don't. You can do it with just numbers, but you cannot. So over here with the remainder, when you put it over the divisor, you have to put either a plus. If this would have been a negative, this would have been a minus. But this is my answer as my long division. Does anybody have any questions on this? Okay, let's see if we can. I'm going to work another one totally out, and then I'm going to give you one to try on your own. And I'm going to put it over on this side so you can still see the steps from that one. But we're going to remember our steps involve divide, multiply, subtract, bring down, divide, multiply, subtract, bring down. So let's say I want to divide -6x minus 11 plus 4x to the third. I want to divide that by 2x minus 4. Again, I could have put it as, set it up as a fraction, or I can set it up using division sign. Again, it is a polynomial divided by a polynomial. It's divided by a binomial. And therefore, we want to set it up as a long division, which means I put the 2x minus 4 on the outside. Notice this is also in descending order. First the x, then the number. And then I'm going to put my dividend, what we're dividing into, on the inside, again in descending order. Now, if I look at this, if it's descending order means I have to have the highest power first, and then the next highest power, and then the next. The next highest power here is 4x cubed, so that has to be the first term that I put. The degree of this polynomial happens to be 3. There's an exponent of 3. So that has to go first. Well, now I think, okay, my first term had an x to the third. My next term was going to be an x squared. Usually they go in order. But I look at that and there's no x squared term. But for when we're doing this division, this long division, we have to not only put it in descending order, we have to account for every term. So I'm going to write plus 0x squared. I could just write 0 there. It's like a space maintainer. I need a space for x cubed. I need a space for x squared. I need a space for x. I need a space for the number. So I leave this as 0x squared. Of course, 0 times anything is 0. It's just there to maintain the proper space so everything lines up properly. The next thing I should see is an x term, and there is one. There's a negative 6x. And finally, there should be a constant, a number without any x's, and there's a minus 11. So not only do we put it in descending order, we make sure if anything is missing, then we account for it by putting a 0 in its place. If everything is set up properly, the example is going to work out much better. You're going to have a lot of trouble if you don't do your setup properly in the beginning. Okay, now we're going to follow the steps that we did before. Remember, divide, multiply, subtract, bring down. So first I divide. When I do the division, I divide by the 2x. So 2x divided into 4x cubed. I only use the first term into the first term. 2 into 4 is 2. X into x cubed. Remember, we subtract the exponents. That gives me x squared. Once I put something on top, the next step is to multiply. I'm going to multiply the 2x squared that I just put on top by the whole binomial. So 2x squared times 2x is going to give me 4x third. And 2x squared times negative 4 is going to give me negative 8x squared. If you notice, I needed the 0x squared to put the x squared term someplace. Because after I multiply, the next step is to subtract. I want to subtract just like I did over here. And remember, we do the subtraction by changing the signs. This is a positive, it's going to become a negative. This is a negative, it's going to become a positive. So that we end up with 4x cubed minus 4x cubed, which cancels out. And 0x squared plus 8x squared, which gives us 8x squared. And step number 4, bring down the next term. The next term is negative 6x. And start the process again. Divide the first term, the 2x, into the first term. Now it's the first term here is 8x squared. 2 into 8 is 4. X into x squared. Remember, we're subtracting their exponents. It gives me x to the 1, which is just x. Again, I'm not being too careful as to where the things go on the top. It doesn't really matter. I don't have to arrange things too well in the in the answer part. But I now have to do, okay, I did the division, I now have to do the multiplication. 4x times 2x is 8x squared. 4x times negative 4 is negative 16x. Don't forget, I have to multiply by both terms. And after I do the multiplication, I have to subtract. Again, that means this will become a negative, and this is a negative, it'll become a positive. So again, we have this 8x squared minus 8x squared that cancel. Negative 6x plus 16x gives me 10x. And I bring down the next term, which is minus 11. And I do the same thing again. I divide 2x, the first term, into the first term, 10x. 2 into 10 gives me 5. And the x's cancel out. So I now take the 5 that I put on top and multiply by it. 5 times 2x is 10x. 5 times negative 4 is negative 20. Okay, we're up to subtracting. That means I change my sign. So this is going to become a negative, and this is going to become a positive. And the 10x minus the 10x cancels. And now I'm left with negative 11 plus 20, which is positive 9. That's my remainder. So my answer comes out to be 2x squared plus 4x plus 5 plus 9 over 2x minus 4. If there is no remainder, if it turns out the remainder is 0, it means that the divisor was actually a factor of the original expression, and it goes in evenly. Does anybody have a question before I give you one to try on your own? Odell's, the reason we're changing the sign is because if you remember, let's say, let me just remind you, suppose I'm doing 5 minus negative 3. If I want to subtract the negative 3, don't you remember what we do in algebra? We change this to a plus by changing the sign. Usually, that's the rule of subtraction in algebra, or in what we call sign numbers, integers. Change the sign of the subtrahend, what you're subtracting, and then instead of doing subtraction, you're now doing addition. So I'm just using the algebraic method of subtraction. It's because you have so many things that you're subtracting, you're more likely not to make mistakes. Yes, you could have done something like this. You could have said, oh, I have to do negative 6x minus negative 16x. Are you going to remember that you have to do minus and minus? It's better to change the sign so you don't make any mistakes as you go along. Is that clear? Okay. So now I'm going to give you one to try on your own. I'm going to leave this one on the board, and I'm going to erase that one, and I'm going to put one on the board for you to try. And while you're doing that, I will take attendance. Okay. Actually, this is one that's on the practice sheet. Suppose I gave you 6x cubed minus 19x squared plus 19x minus 2. And I want you to divide this by 2x minus 3. See if you can come up with a solution for that while I take attendance. See if we can get the right answer here. Okay, so what we want to do is set it up like a long division example, because it is actually 4 terms divided by a binomial. So we're going to put the 2x minus 4 on the 3 on the outside. And I'm going to look at this. It is in descending order. It starts with the 6x cubed, so it's good. The next thing is an x squared, so that's minus 19x squared. Then we have the plus 19x and minus 2. So it was set up, nothing is missing. Everything is set up the way it's supposed to be. Okay, so now let's start the steps. Remember, our basic steps are divide, multiply, subtract, bring down. So, and I always start with just the first term, the 2x. So 2x, I'm going to divide into 6x to the third. So the 2 into the 6 goes 3, and the x into the x third gives me x squared. Remember, we're subtracting exponents. I take what I put on top and I multiply by the whole divisor. So 6x squared, 3x squared times 2x is 6x to the third. 3x squared times negative 3 is minus 9x squared. And then, okay, we multiplied, so now we have to subtract. And remember, I like to do the subtraction by changing the sign. So I'm going to make this 6x squared cubed negative, and the negative 9x squared is going to become positive. So now I can just combine them. 6x cubed and negative 6x cubed cancel. Negative 9x squared plus negative 19x squared plus 9x squared give us a total of negative 10x squared. And I bring down the next term, which is plus 19x. And start the process again by dividing 2x into negative 10x squared. So 2 into negative 10 is negative 5. The x divided into the x squared gives us x. And I now take what I just put on top, which is negative 5x, and multiply by it. Negative 5x times 2x is negative 10x squared. Negative 5x times negative 3 is plus 15x. And now I subtract. Again, I'm going to subtract by changing the signs. This is going to become a plus. This is going to become a minus. So now I'll have a negative 10x squared plus a positive 10x squared, which will cancel. And I'll have a positive 19x minus a 15x, which is positive 4x. And bring down the next term, which is negative 2. And I start the process again by doing dividing. I take my first term, which is 2x, and divide it into 4x. So the 2 into 4 gives me positive 2. Remember, the x's are now canceling out. I now take that 2 that's on top and multiply by it. 2 times 2x is 4x. 2 times -3 is -6. Again, I want to subtract, so I'm going to make the 4x a negative and the -6x a positive. So the 4x minus the 4x canceled. -2 plus 6 gives me +4. There's nothing more to bring down. This is my remainder. So my answer comes out to be 3x squared minus 5x plus 2 plus my remainder, which is 4 over 2x minus 3. Put the remainder over the divisor. How many people were able to get this one correct? Anybody got that right? Great, Jessica, that's amazing. Because this is
Can I
hot.
see the board, please?
Yeah, sure. Is that okay? Can you see okay?
Yes, I can. Thank you.
All right. So this takes care of the last topic in chapter 5. I'm going to be giving an introduction of some information that we're going to need in order to go on to chapter 6. Chapter 6 is about different kinds of exponents, fractional exponents. We're going to talk about what that means, and also about radicals. So that's what that chapter is going to be about. When we complete chapter 6, I'm going to give you your next test. In the interim, make sure to look out for examples on the Delta math. Keep current with your homework. Before we go on to chapter 6, I want to just review the rules of working with exponents, because we're going to be doing a lot of exponent work in chapter 6, and I want to make sure that you know all the rules clearly. Okay, can I erase what's on the board now? Okay. We've been doing examples that involve exponents, but as we go further into this, I want to just review the rules and go a little bit further in some of the things that we haven't mentioned before. So let's talk about the various rules that apply to working with exponents. Rule number 1 is if you have something like a to the 6th times a to the 4th, where you're multiplying two numbers or two variables, which represent numbers, obviously, and they're the same, your bases are the same, the numbers that have the exponents are the same, then the rule is what you do is you add the exponents. So a to the 6th times a to the 4th is a to the 10th. When it comes to division, let's say I have a to the 6th divided by a to the 4th. Then we do subtraction. And actually, the way we said that we will do this, if you recall, because we just were doing this before, what we do is really we reduce it by crossing out or canceling out the letter with the lower exponent and subtracting the higher exponent minus the lower exponent. 6 minus 4 is 2. This gives me a squared with a 1 on the bottom, which is just a squared. Always remember that when you're canceling out, that you always leave your answer where the higher exponent is. The lower exponent gets canceled out and you're left with a higher exponent. This will always allow you to have a positive exponent because you don't want to end up with a negative exponent. The third rule has to do with if you have a variable or a number with an exponent and you raise it to a second exponent. What do you do when you have two exponents on a number? If you recall, the rule is you multiply the two exponents together. So this will give you a to the 18th. If you have two letters, let's say you have a squared b third, that's raised to, let's say, the fourth power, where you have more than one variable or a number and a variable, you have to distribute the exponent to each of those factors. So this will give you, you'll do the a squared to the fourth, which will give you a to the 8th, and the b third to the fourth, which will give you b 12th. And one rule that we probably never mentioned before, but you probably know already, is that anytime you have anything to the 0 exponent, that answer is going to be equal to 1. So these are the basic rules that we apply to working with exponents. And we have to keep remembering that we're always using these rules. So if I were to have given you a problem that looks like this, suppose I gave you 3x squared y 8th to the fourth power over 9x fourth y third to the second power. And I ask you to simplify this. We would follow a combination of these rules. Rule number 1 is always remove the parentheses. Take care of the parentheses first. Now, if I look at the numerator, there is a parentheses and there's a 4 exponent on the outside. That means I've got to distribute this 4 exponent to each one of these, what I'll call them factors. The 3, the x squared, and the the y 8. So this will give me 3 to the fourth. Don't forget, it means even the numbers, not just the letters, but the numbers as well. X squared to the fourth, well, that means multiply the two exponents. That gives me 1, x to the 8th. Y 8 to the fourth gives me y to the 32. That takes care of the numerator. In the denominator, I'm going to do 9 squared, 9 to the 2, x fourth to the 2, which is x 8th, and y 3 to the 2, which is y 6. And now I have to simplify this. Now, first of all, I have to deal with these coefficients. What is 3 to the fourth? It means 3 times 3 times 3 times 3. A positive exponent is really just telling you how many times you are multiplying the number. 3 to the fourth means I'm multiplying 3 4 times, and that gives me an answer that is 81. Similarly, the 9 squared is 9 times 9, and that's also 81. So now I have everything expanded. I can now reduce. First, I deal with the coefficients. 81 and 81 just cancel out. Then I look at the x's. X8 and X8 just cancel out because they're the exact same exponent. And Y32 and Y6, we cancel out the lower one, which means I'm left with a 1 on the denominator. And I subtract the exponent from the higher one, which is in the numerator. 32 minus 6 is 26. So that my final answer, the only thing I'm left with is y to the 26th over 1, which is just y to the 26th. Remember, when your denominator is 1, you do not have to put it in. Are we okay with that?
Yes.
Okay. So let's see. We've done these type of examples before. I want to go one step further and talk about what happens when we have a negative exponent. We're going to see that sometimes our exponents are negative and sometimes our exponents are even fractions. And we're not going to deal with the fractional exponents now. We're just going to talk wouldn't it be 8? Alexander, what would be 8? 20, yes, you're right. 26 minus 6 is 20. No, wait, 32 minus 6.
No. I meant about the I misunderstood that you have to multiply everything, so I thought the 3 would be 8, but that's the x. That would be 8, and then the 3 would get the 4. Yeah, I misunderstood.
Great, thanks for telling me. Okay, so now let's talk about what happens when we have negative exponents. All the rules that we just mentioned in terms of exponents always work, whether your exponents are regular whole numbers, regular positive integers like these, or whether your exponents are negative integers, or whether your exponents are fractions. But let's explain what we mean by a negative exponent. And here's what it means. If you see something like a to the negative 2, what that really means is 1 over a squared. To have a negative exponent means that your variable should be in the denominator rather than in the numerator. It doesn't make your answer negative, it makes it into a fraction. Now, that being the case, how do we deal with negative exponents? Usually what happens is that when we have a negative exponent, what we'd like to do is make sure that to simplify my answer so that in the end, I'll only have positive exponents. And I'm going to explain to you what to do. I'm going to show you a long way that I don't want you to write down. I just want you to listen. And then I'm going to give you a short way to deal with it that's much simpler. But I want to do the long way so you'll understand why it works. Suppose I gave you a to the negative 2 over b to the negative 2. Now, when I say I want to simplify this, I really want to end up with no negative exponents. Okay, just listen. The a to the negative 2, we said, means 1 over a squared. That's what we said it's defined as. The b to the negative 2, obviously, that means 1 over b squared. So actually, what this thing means is 1 fraction over another fraction. Well, this is really complicated. As a matter of fact, the term for this type of thing is called a complex fraction. A fraction over a fraction is a complex fraction. And we don't want something so complicated. So we want to simplify this. Well, if I think about it, the fraction really means to divide. So it means 1 over a squared divided by 1 over b squared. And when you're dividing fractions, what you do is you take the reciprocal of your second fraction and multiply. So this really means 1 over a squared times b squared over 1. There's nothing to cancel out, so I just do 1 times b squared, which is b squared, over a squared times 1. And my final answer comes out to be b squared over a squared. Okay, now I'm going to show you a short way how you could have gotten to that. Remember, we started out with a to the negative 2 over b to the negative 2. Here's what I do. Here's the easy way to handle negative exponents. Here's my fraction line. If I see something that has a negative exponent, then I take it from where it's standing right there and move it. What does that mean? I move it. If it's in the numerator, I move it to the denominator. If it's in the denominator, I move it to the numerator. If the exponent is positive, I just leave it where it is. But if the exponent is negative, it means you want to take its reciprocal. You want to put 1 over it. That means take its reciprocal. And you do it by moving it from where it is, the numerator to denominator or denominator to numerator. Well, let's see how that works. This is an a to the negative 2. Its exponent is negative. Since it's in the numerator, I'm moving it to the denominator and making it positive 2. There's nothing else in the numerator, so I go to the b to the negative 2. It's in the denominator, so again, I have to move it because its exponent is negative. I have to move it up, so that'll go b squared. And notice that right away gives us the answer that we were looking for. So let's keep in mind when we see negative exponents that what we're going to do with them is we're going to simplify it by simply changing the position. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And that way you'll get your exponents to be positive. So that being said, let's do a little more complicated example. I'll do a complicated one, and then I'll give you one to try on your own. Okay, so let's say I gave you this example. X negative 5, y squared over x negative 3, y negative 4, all raised to the negative 2 power. Obviously, this is a lot more complicated than this one, a to the negative 2 over b to the negative 2. But we're going to use all the regular rules of exponents to simplify this. The first thing, if you recall, I told you to do is try and remove any parentheses you see. Now, there is a parentheses here with a negative 2 exponent. That means I have to distribute this negative 2 exponent to each one of these variables, to the x negative 5, to the y2, etc. And we do that, we know when we have something with an exponent raised to another exponent, what we do to the 2 exponents is we multiply. So x to the negative 5 to the negative 2 is going to give me x to the 10, because negative 5 times negative 2 is 10. Then y squared to the negative 2 will give me y to the negative 4. I'm just writing down what I'm doing. I'm removing the parentheses. X to the negative 3 to the negative 2 gives me x to the 6th. And y to the negative 4 to the negative 2 gives me y to the 8th. That right away simplified something somewhat. What do we do now? Now we move things. We move anything with a negative exponent. If it has a positive exponent, we let it stay where it is. If it has a negative exponent, it gets moved. So here's my fraction line. I go through each item. X to the negative 10. The exponent is positive, stays where it is. Y to the negative 4. Oh, that's the negative exponent. It's in the numerator. It has to get moved to the denominator. It becomes y4 in the denominator. Okay, continuing. I have an x to the 6th. Its exponent is positive. It stays where it is, which is right in the bottom. And y to the 8th is also has a positive exponent, so it also stays on the bottom. And what we're left with to do is to combine the like variables. First of all, the x6 and the x10, one's in the numerator, one's in the denominator. So I can cancel out the lower one, which is the x to the 6th. 10 minus 6 is 4. I'm left with an x4 on the top. And the two y's happen to both be in the denominator. So I am multiplying y4 and y8. And I know when I multiply, I add their exponents. So this becomes a y to the 12th. So that my final answer becomes x4 in the numerator and y12 in the denominator. And that's, notice it has no negative exponents, and everything that we could possibly combine could combine. Does anybody have any questions about how to do that?
No.
Okay, so then let me give you one to try and see if it really works. Let me see if I can find one from an old exam. Okay, here's an example. We have x squared to the negative 3 times x to the negative 5th to the 0 over x to the negative 8. Now this is a multiple choice question, so here are your choices. 1 over x to the 14th, x to the 8th, x to the 18th, and x squared. See if you can simplify that and get it without, here's the instructions. It says simplify and make sure there are no negative exponents. Okay, see if you can do that. Okay, I think we should try it together. If we're going to follow our rules, the first thing we're going to do is try and deal with the parentheses. The first thing I see is an x squared to the -3. So I know I have to multiply the 2 times the -3. That'll give me x to the -6. X to the -5 to the 0 power. Remember, we said anything to the 0 power is just equal to 1. Doesn't matter if it's x to the -5th, if it's 25 to the 0 power, x to the millionth power to the 0 power, anything to the 0 power is going to give us 1. And the denominator stays x to the -8. So we removed our parentheses. Now we're going to move things. The x to the -6 has a negative exponent. It has to get moved. Goes to the denominator is x to the 8. The 1 stays where it is because an exponent, if a number doesn't have an exponent, it's understood to be 1, which is positive, so it just stays where it is. The x to the -8 has to get moved because it's got a negative exponent. Since it's in the denominator, it moves to the numerator and becomes x to the +8 in the numerator. Now we're going to try and reduce. Notice there's an x6 in the bottom, x8 in the top. The lower exponent is the x6, so that gets canceled out. We get a 1 there. 8 minus 6 is 2. That gives me x squared on the top. So my final answer comes out to be x squared, which is choice 4. How many people got choice 4 as the correct answer? Anybody? Okay, great. Nope. Do you understand it now, Alexandra? Okay, great. Notice you have to do it step by step. Don't try to skip any steps. Don't try to do 2 steps at once. Remove your parentheses by applying your outside exponent to everything on the inside. Remember, when you have 2 exponents, they have to be multiplied. And secondly, after that, move anything so that you only deal with positive exponents. If you have a negative exponent, it has to get moved. If you have a positive exponent, leave it where it is. And then cancel out any like examples. Okay. Okay, so I think that's where we're going to stop today so that we can start with chapter 6 on Tuesday. Don't forget any material that you haven't done. If you at this point, you should have finished 4 tests, 2 on Blackboard, one of which is the actual midterm, and 2 on Delta Math. Our next test will come up after we finish chapter 6, and then we'll continue from there. Again, don't forget to do the homeworks. You must get, on the homeworks, you must make an attempt on them in order to get complete credit. You should, the only thing that you don't get credit for on a homework is if it says 0%. If it even says 10%, in terms of a homework, it's considered done. But the tests are tests that you get marked on. If you get a 10% on a test, that means you're getting a 10 out of 100 on a test. And that's what's going to be your mark, your final grade on this course consists of 10% homework, 20% tests and quizzes. That means tests and quizzes on Delta Math and Blackboard. 10% is your midterm, so we're up to 40%. And your final exam, which will also be given on Blackboard, is going to be 60%. Does anybody want to ask me something? Don't forget to complete your midterm by this evening. If you haven't done it yet, get it done by this evening. If anybody has a reason that they need extra time, let me know. And if you have run out of time on any of the homework or assignments, let me know and I can reset them for you. Okay, have a good weekend, everybody.
Good weekend. Bye-bye.
Bye-bye.
Bye.
Have a good weekend.